Hello. First of all, I would like to thank all the community members for organizing this interesting event. At the same time, I would like to thank all the presenters for their valuable content. My name is Abdulrahman Kerim. I got my first BSc in Electronics and Communication Engineering and my second BSc in Computer Engineering. Currently, I'm doing my PhD at Lancaster University, UK. My field of interest span different domains like artificial intelligence, machine learning, computer vision. At the same time, I'm interested in synthetic data generation and data mining. The presentation is divided into three parts. In the first part, we will discuss introduction and related work. In the second part, we will mention the contribution and methodology of this work. In the third part, we will cover analysis and conclusion. The main problem that we are considering in this work is a traffic signs recognition problem. This problem was selected because it's critical for many industries, especially for autonomous cars. Accuracy and low time complexity are the main two things that are required in order to develop an optimal solution for the problem. The lack of a unified benchmarking procedure is one key problem in this domain. Now we use artificial neural network to tackle this problem. Artificial neural networks are known as a good function approximators. ANN actually does very well at highly nonlinear problems. They can learn the mapping between two domains once they are provided with data that represent the relation implicitly. However, the main key disadvantage is that ANN requires a lot of labeled data. Now, one solution to mitigate this problem is to augment the data. Now the key differences among the related works: first, the feature extraction method; second, the process of combining or fusing these features to classify traffic signs. So using hug and color intensity features for classification was done in one of the works. Other work also investigates using attention mechanism for the traffic sign detection and the classifications, while other works investigated using adaptive neurophysics inference systems, plus using geometry information to enhance the traffic sign recognition. So, as we have mentioned, there are a lot of data sets for recognition, like the Russian traffic sign dataset, Swedish traffic sign dataset, Netherlands traffic sign dataset, French traffic sign dataset, German traffic sign recognition benchmark, and Chinese traffic sign database. Our novelty and contribution can be summarized in the following 2 points. First of all, a novel dataset combining two famous benchmarks using structural similarity index measure. And the second thing, a hybrid artificial neural network that achieves accurate results that are very close to the state-of-the-art ones. Combining the two datasets. First of all, we inspect the classes of both datasets and merge the same ones. Following this, we split the datasets into training, validation, and testing sets. We follow the rule of thumb. We take 80% for training, 10% for validation, and 10% for testing. We note here that we don't have any overlapping samples among the sets. After that, for the data augmentation, we use translation, rotation, noising, color and intensity jittering, blurring. Now for best sample selection, for each image we calculate its similarity index with randomly selected 100 images from the same class using SSIM measure. After that, we sort the images with the lowest similarity score. Following this, we pick the first 600 samples with the lowest score. It means that we select the most diverse samples per class. Now you can see here in this figure the diversity and the challenging nature of these samples. For each row, you see one specific class. Now for the hybrid ANN that we are proposing, you can see in this figure that it consists of three major models. We have the color model, the histogram oriented gradient model, and the local binary pattern model. Now for the color model, we have the red, green, and the blue submodels, and the same thing for the hug and for local binary pattern. We have different variation for the cell size. That will allow the model to capture different level of details regarding the image that we are trying to guess its a traffic sign class. So after that, these submodels will make the predictions for the category of the traffic sign, and using some simple majority voting mechanism, we decide the final class. In one of the experiments, we ask which features are more critical for traffic signs recognition. For that reason, we do the training and testing on our dataset. Our results reveal that local binary patterns features are much more robust as compared to color or hug features. The reason could be that the color and hug features are very sensitive to light intensity and recording noise. In other experiments, we see that combining color, hug, and local binary pattern features achieve the optimal performance compared to applying one model on its own, as you can see in this table. To sum up, in our work, we present a novel dataset that combines TSRD and GTSRB datasets using data augmentation and SSIM techniques. We show that using color, hug, and local binary pattern features can improve the accuracy of the classification model considerably. There is a clear trade-off between system accuracy and time complexity. So as we mentioned at the beginning, the best solution is to try to maximize the accuracy and minimize the time complexity. SSIM measure was preferred on other measures because it models better the precise structural information of images, and it is much more robust as compared to other measures. Finally, I would like to say thank you very much for your attendance.